Hello everyone, I'm a representative on Group 3 and this is our example of a first order circuit. So as what we have seen so far for the first order circuits, we have two kinds of it. The first one is RC, where you can expect to find a capacitance, and then an RL, where you can expect to find an inductor. So let's move to our example. As we can see here, we have an inductor over here, so that suggests that we have a RL circuit. So suppose the switch in the circuit has been closed for a long time, and at t equal to 1, the switch will be opened. Now let's say that we want to calculate the current flow when t is more than 0. Over here, we want to calculate the current flow ILT over here. So firstly, consider the case where t is less than 0. So the switch here will be closed and the inductor will act as a short circuit, which means we can we can ignore this with 32 ohms resistance over here because there's no current flow, because this is over here it is a short circuit. So after that, we have to find the I when time is less than 0. So to do that, we have to find an equivalent circuit first. So we ignore this, and we can see that 8 is in parallel with 8 ohm resistor is in parallel with 24 ohm resistor. So we use our formula, and then we obtain 6. And then once we obtain 6, we certainly know that 6 ohm resistor is in series with the 4 ohm resistor. So we use the formula again, and then we obtain R equal to 10 ohm, and then we use another formula, that is a current division, to find the I, which is, in this case, I is equal to V over R. So we already know V as 80 volts, and then R, we just obtain it, that is 10 ohm. And then we get the current flow when I is less than 0, that is 8 amp. Once we obtain the current flow from the voltage source, that is 8 amp, now we have to find the current flow through this resistor, through this 8 ohm resistor, that is IL, again when time is less than 0. So we have to find the current flow through here, which we can use the formula current division to find the current flow. So over here we can say that R2 in this case is 24, and R1 plus R2 is 8 plus 24. We've obtained 0.75. Now multiply with our current flow coming out of the 80 volt voltage source, which is 8. We then obtain 6 amp. So we know that the current flow through here is 6 amp. Now we can find the current through. We can calculate the current flow when time is more than 0, which is our main objective. So the current through the inductor when the time goes to infinity, we certainly know that it is 8 amp. And then we use the formula again. We use this formula to find our current flow when time is more than 0. So substitute the number over here, which is 0, and then this IL when the time is 0, we got it as 6 amp and 0. E, raised to the power of t minus t over this constant, which we can obtain by ignoring this one and this one. We can focus on this part to obtain the third constant, which will be L in inductor over here over equivalent resistance, which if you calculate, you can see that this 8 ohm resistor is in series with this 24 ohm resistor. Once you get that, you will get 32, which now in turn will be parallel to this 32 ohm over here. So when you get that, the formula to find this constant is L over the equivalent resistance circuit, which would be 4 over 16, which is also 1 over 4, which is equal to 0.25 over here, and then we get our answer. This is the current flow when the time is more than 0. So that's it. Thank you for your